Here's a mean value theorem application for f of x equals x minus 1 over x. I don't know how that really behaves in that function. I'm going to graph it first to kind of see what it looks like, and then to see if there's what conditions, if the conditions are met. I graphed that on Desmos, and it looks like this. That function kind of has an asymptote at vertical asymptote at 0, and then at 1, 2, 3, and 4, it looks like this. So there's definitely a discontinuity, which makes and also it's not differentiable at x equals 0. But because we are just interested in the interval from 3 to 4, we are pretty good to go. Because, let's see, f of 3 is, let's see, that's 3 minus 1/3, that's 2 2/3. Oh, this is not easy. 3 comma 2 2/3, and that's the point 4. 4 minus 1/4 is 3 3/4. So mean value theorem states that if conditions are met, there's going to be a C where the slope of the tangent line is equal to the slope of that secant line. Now, I'm just guessing, but I think that it's kind of hard. I'm going to zoom in here. There's the red one is the slope of the tangent line. Probably something where the slope of, sorry, that's a secant line. I'm going to find a C right about there where those lines are parallel. You always got to meet conditions of the mean value theorem to make sure that you are able to use it. So f of x is continuous over the interval 3 to 4 and differentiable in the open interval 3 to 4. As I look in that, there's no places where I pick up my pencil. I can find the derivative anywhere within that open interval. Conditions are met. So by the mean value theorem, there is a C within that interval 3 to 4 such that f prime of C equals the slope of the secant line between 3 to 4. So f of 4 minus f of 3 over 4 minus 3. Okay, let's chug it out. Hard stuff first, finding the derivative and finding f prime of C. F of x is x minus 1 over x. I'm going to write it as x minus x to the negative 1 because I prefer to use the power rule instead of the quotient rule. So f prime of x is 1, and then let's see, quotient rule, sorry, power rule plus x to the negative 2, 1 over x squared. So f prime of C is going to be 1 plus 1 over C squared. That's on the left. We're going to have to resolve that and isolate C eventually. 1 plus 1 over C squared. F of 4 minus f of 3 over 4 minus 3. Oh man, back to those funky fractions. That's 3 3/4 minus 2 2/3 all over 1. That means 1 plus 1 over C squared equals, man, 3 3/4 minus 2 2/3 is the same as, let's see, I'm going to move over here and work that. That's 15/4 minus 8/3. We need common denominators. That's 12, so that is really 45/12 minus 32/12. That's 13/12. So that means 1 plus 1 over c squared equals 13/12 over 1. All right, let's subtract 1. So 1 over c squared is equal to 13/12 minus 1 is the same as 13/12 minus 12/12, and that's 1/12. Okay, so now I would definitely cross multiply. And that's going to do the magic of clearing that fraction. So c squared equals 12. And c equals square root of 12, which is, let's see, 4 goes into 12. That's a perfect square. 2 radical 3. And that is roughly a little more than 3.46. So I should say plus or minus 2 radical 3. But plus 2 radical 3 is our answer, because negative 2 radical 3 or negative 3.46 is not within our interval. So we can eliminate it. We are just looking for 2 radical 3, which is somewhere up there, which is confirmed that that's the place where the slope of the tangent line equals the slope of the secant line. We found our c. C equals 2 radical 3.